Okay, this is a video for help with number 17 in your AP packet. Question is on the screen. So I'm starting this by thinking the same thing I always do when I'm doing an equation of a tangent line. So I'm going to be thinking y minus y value, and they gave you the point right here. So minus a negative 1 equals m, which is going to be my slope. Remember in calculus class, our m is our slope. So I'm going to leave a blank for that. Let's put m for right now, x minus 2. And now we'll change that to a plus, a positive. And all I really need to do right now is I need to find my slope. So if I can find a slope, I can put that in, and then I've got my equation, my tangent line. And it appears, based on the answers, we're going to have to rearrange that a little bit, but it's totally doable. So what I need to do is I need to make the connection that a slope in calculus is a derivative when I want a slope at a particular point in time. So I'm now looking at the equation that I'm given, and I'm going to take the derivative. So remember, we're doing implicit differentiation here unless I want to solve for y. And I don't think I want to solve this for y because I'm going to end up with a square root. So I'm going to take the derivative as is and just make sure I do implicit. So take the derivative regularly, but if it's not an x, because I'm taking a derivative with respect to x, I'm going to multiply by dy dx. So 18x, first term's fine, plus 16 times 2 is 32y, and now here's where I'm going to have to multiply by dy dx equals derivative of 52, derivative of a constant is 0. So that's me taking the derivative with respect to x, I should have written it this way, of each side of this equation. And now I'm going to solve for dy dx, and then eventually evaluate it at 2, negative 1. So dy dx, I'm going to subtract my 18x and then divide by 32y. So I know I did 2 steps at a time there, but let's go ahead and simplify that. 18 and 32 both reduce by 2 for sure, negative 9x over 16y. Yeah, I guess that's it. So that's my simplified derivative, and then the last thing I want to do is evaluate that at x equals 2 and y equals negative 1. Sometimes we use this vertical line to show what we're evaluating it at, and then we're going to go ahead and just substitute in there. So negative 9 times x value of 2 over 16 times y value of negative 1 gives me slope of negative 18 over negative 16, which is negatives cancel, and I get 18 over 16 reduces to 9 over 8. So my slope is 9/8. Put that back in there for my m, and then you're just going to rearrange that. It looks like everything's solved for 0, so we call that standard form for the equation of the line. And you're also going to have to get rid of the fraction, so I would multiply everything by 8. See what you can do with that.